virtual warehouse will be charged based on the credits. Nothing what? They will measure the charge or cost. So based on the number of credits you use, suppose if you use X small, virtual warehouse, so for 1 hour they will allocate you 1 credit. For 1 credit, how much they need to pay? How much they need to charge? They will see for 1 credit $2.7, $4 for different edition, $5.4 into another edition. Suppose if you use large, for 1 hour they are going to consider 8 credits. 8 credits into $2.7 for this edition. 8 credits into $4 for this edition. 5.4 into 8 credits for this edition. So based on that, they are going to charge you guys. Have you clear about this virtual warehouse calculation or not? Tell me.
Yes.
Confirm me, everyone. Confirm me, everyone. If you clear, then I will proceed further.
Yes.
Clear, yes, right? So this is about the hardware component usage calculation. What about the storage? See, if you have taken Snowflake subscription. Suppose let's consider this is the January month. So your organization has assumed that the business is going to start from the January, but unfortunately the business got delayed. Already you have taken the subscription, but you are not using. In such case, you need to pay $25 per month if you are not using anything, but you have taken a subscription. And or if you have taken the subscription and you have started to use your Snowflake. In this case, for 1 TB you need $2. For 1 TB you need to pay $40 per month. If you use 100 TB, 100 into $40 per month you need to pay. So the cost will be in two ways actually. You need to pay for the storage and you need to pay for the compute, virtual warehouse. So this is the way they are going to charge you guys. Is this clear or not? So this is minimum $25 you need to pay if you are using, if you are not using. Suppose if you are using, you started to load the data, so you need to pay $40 per TB. If you use 500 GB, then it will be divided into that part. So like that it will go. So this is about the pricing details on your hardware resources and your storage component. Clear or not?
Yes.
Yeah. So these are the different virtual warehouse sizes. So these are the credits. These credits are very much important. So based on these credits, they have already defined. Boss, if you created your virtual warehouse with the medium size, so in this case, we are going to allocate you 4 credits per hour, and then 4 into, so based on the edition, and then the $2.7 like that they are going to charge you. So this is very much important. You have to understand what is the different size of warehouse sizes and what are the credits, how they are going to start pricing on you. So this is about the pricing. If you have any doubts in the understanding on the pricing, just let me know. We will discuss and then we will proceed further. If you are clear, just confirm me. Then we will discuss next topics. And also, always I am trying to tell you, please make a note somewhere as a running note. Sure.
Yes, sir.
Guys, clear or not clear?
Yes, sir.
Okay, fine. Then we'll go to discuss that different editions are available in the Snowflake. Different editions. We have a 4 editions actually: standard, enterprise, business critical, virtual private. So I'm repeating once again. So you need to make a note also. So we have a standard edition, we have an enterprise edition, we have a business critical edition, we have a virtual private edition. So these are the 4 types of editions we have in Snowflake. In general or in projects, we are using this business critical. We are using this business critical uh, edition for our business purpose. We are using this business critical for our business purpose in our companies. Then we'll see what are the options are available. What are the different benefits or great features are available in the each editions. The standard is very basic edition. Very basic edition. Very basic edition. Here, whatever the data is you are going to store, that is in a encryption format. Time travel is up to 1 day. Now, the time travel is one of the great feature in Snowflake. What is the meaning of the time travel? Time travel means, suppose already I have explained in very first class, but let me repeat that one. Time travel nothing but if the data is modified from the table. So after modification of the data from the table, so you came to know that. So this is not the whatever you have done the modification, then that is not that is not a good modification. You need to restore the original data into your table. So in such scenario, in Snowflake has provided you a option, the time travel option. Nothing but you can go back to the history of the table, and then you can bring the original data and restore the original data to table. So in the standard edition, this history will be available for only 1 day. So suppose if you crossed, no, if you done the modification to the table today 6 o'clock, till tomorrow 6 o'clock, you can able to go to the history of the table and then bring the original data and then restore the data. It will available for only 1 day. If you cross that 1 day, then it is not possible. And then what about the disaster recovery? Disaster recovery nothing but suppose if databases go offline, then you can able to bring that into online. What about this data share? Data share nothing but a secure data share. So you can able to share the data between the Snowflake accounts. This is about your standard edition. Coming to the enterprise edition, whatever the features are available in the standard, that will be available. That is very basic. Second one is multi-cluster warehouse. Yesterday we have discussed single warehouse and then multi-cluster warehouse. In standard edition only you can work with a single warehouse. This enterprise edition will be supporting the multi-cluster warehouse also. This time travel in enterprise edition will be there for 90 days. In case of standard, time travel will be available only 1 day. In case of enterprise, time travel option will be around till 90 days. So this is a great feature actually. So suppose 90 days means if you have done your modifications today, till 90 days, if you want to bring the data, then it will be available for the 90 days. So within that time, any time you can able to go back to the history of the table and then bring the data. And then next, what is this materialized views? Materialized views, one of the concept in Snowflake which is used to improve your improve the performance of your SQL query. Suppose your select statement is taking around 5 seconds to return the data. On top of that, if you create a materialized view, then you can able to bring the data in within 1 second. The beauty of this materialized view is it will improve the performance of your SQL query. It will improve the performance of your SQL query, where your SQL query is taking 1 minute, but your materialized view will give the result within a fraction of seconds. So that is the great feature of great benefit of your materialized view. Search optimization, column level security, these things and all provided in enterprise option. In business critical, so whatever the features are available in the enterprise edition, by default that will be there. Additionally, all the objects, all the things are encrypted everywhere. All the options, whatever you are going to create the objects, those are encrypted everywhere in the internally. We can't see those encryption and all, but internally it is happening. Internally it is happening. So that is a great feature. What already enterprise edition has the so many features. Those features are available with the business critical plus this data encryption everywhere, and then failover and then disaster recovery. So failover and then disaster recovery, nothing but if your database is crashed, and then you can able to bring bring that database into online, So this is the great feature in the business critical edition. What about the virtual private? All business critical features are available in the virtual private, and then the extra is you need to create a separate environment, separate servers for different environments. Suppose if you are maintaining QA server, if you are maintaining testing server, if you are maintaining dev server, if you are maintaining production server, so for that you need to create a separate servers in your virtual private. So this is about your Snowflake editions, guys. Any doubts in this? These are some theoretical parts. You will get the interview questions. What are the different types of editions are available in Snowflake, and explain them. And also you will get the what is warehouse, what is multi-clustering warehouse, and what is the Snowflake architecture, how many layers are there, what are the functionality of those architecture. Can you explain all those things? These are the theoretical concepts. So you have to, for sure, you have to remember, understand, and explain thoroughly. Whatever we are discussing in the sessions, if you understand that and explain it clearly, whatever we have discussed here, that is 100%, 1000% more than enough, guys. That's why I am asking you. I will share you the note. Along with me. You also prepare your some points in your notes, so that you will check the material and then you will check the note, so you will become a comfortable. If you get any doubts, again you will come back to me and we will discuss on the same topic, so that you will become a comfortable. So this is about the editions, guy. Any doubts, let me know. Just open your mouth, guys.
No, sir, but I wanted to know, in a typical real-time environment or a real-time project, typically a dev or QA or a production environment, what are the additions might be there? I mean, will be there. Whether the dev will be having only standard edition, or whether the QA having enterprise edition only, or the production might.
Usually in our real scenarios in organization, we all are using business critical for all the requirements.
Okay.
Next question. If you don't have any questions, then we'll move into another topic to discuss.
No, sir. Understood.
Fine. Yeah, then we'll go how to connect to Snowflake. Web user interface. Second one is NoSQL through the DOS command. Through the DOS command. So we can able to connect your Snowflake. You can able to connect your Snowflake using your web user interface or using Snowflake or no use NoSQL using DOS command. And also apart from this, we have some other options also, but majorly we are using these two options only. Some other options also available, JDBC drivers, ODBC drivers, those things and all. But in real time scenarios, as per my experience, we have used only these two options. Only these two options. Then, as part of our regular classes, daily we are using this web user interfaces, this NoSQL and then DOS command things. We will be having the one session, how do we use this NoSQL. Then now we'll see how to create the Snowflake account. How to create the Snowflake account. Fine. You need to follow the steps and create yourself. And then we'll explore what are the options are available in your Snowflake account. Then go to Google. So here, make a note somewhere. Snowflake.com. Snowflake.com. Guys, have you make a note? Snowflake.com.
Yes.
I need confirmation from all, because you need to create account from your end. This is the free account. This is a free account. It will be available for the 1 month. You can practice in that environment. You need to create. Which is very easy step. You can create from your end also. Just you need to follow what I am doing, right? Just this is snowflake.com. Enter the snowflake.com. Then you will get into this home page. Click on the start for free. Click on the start for free. So here, provide your all the details. First name, I will give the Durga Soft. Email ID, I will give my email ID. It will go into that. I will give the company name as Durga Soft. Role you need to select consultant. Location you need to select as a India. Guys, are you following or not?
Yes.
Yes.
So you need to give your personal details here. So once you have given everything, just continue. Click on the continue. See here, you need to select edition, standard or enterprise or business critical. I am selecting a business critical. You need to make a note down. You need to select a business critical option. This is the option to select the edition. Once you select the business critical, this is the option to select the cloud provider. You need to select the AWS. Guys, you are following or not?
Yes, fine.
Yeah.
Super. So you need to select the AWS. See here, it is asking continental information. So as we have selected India, just select this Asia Pacific, Singapore. Then click on the get started. Click on the get started. Click on the get started. Now it will ask this many options. You can skip this one. You can skip this one. You can skip this one. See, now you are now signed up. An email to activate your account has been sent to your email ID. I will log in into my email ID. Here you will get one link to activate the account. Snowflake.com. Activate your Snowflake account. Click on this. Click to activate. Click to activate. Then it will navigate to this page. Now give the username and then password. So this is the key here. You need to make a note this username and then password. I will give the Durga soft user 11. One second. So you need to give the username and you need to give the password and confirm password and then get started. So this is your home page of this is your home page of your Snowflake account. You need to make a note down like this. This is your account URL. This is username. This is password for your account. You need to save somewhere so that you can able to log in daily and then work. So this is the your when you create an account, then you will get this page at very first. Have you make a note down all the steps, guys?
Yes, sir.
See, when you get here this option, first option is worksheets. If you click on this worksheet, see here, you will have a plus worksheet. If you click on this, so from this option, from here you can able to query your SQL queries in this area. So this is one of the option. So worksheets where you are going to write your SQL queries. Next, data. So here you can able to create the database. Fine.
Yes.
So here if you want to create any new database, you can able to create new database. If you want to create any schemas, then you can able to create the new schemas from here. Like that. See, first one is worksheets is important, data is important, and then this in admin, here we have warehouse option. Here you need to create your warehouse. So these are the three options you have to understand. So once go into your worksheet, then click on this latest one. So here you can able to create your own database. Create database, sample database. So here you can able to see your sample database like that. So for now, just whatever we have followed the steps, you create from your end and then start exploring on the things. Whatever you can able to explore, you can explore, and whatever you need to understand, you can understand. So from tomorrow onwards, we will start using the coding and then the actual Snowflake uh, practical sessions. But before that, you need to create an account and be ready with, align with me, so that whatever we are going to discuss in the session, as a theoretical part and then coding part, I am going to share with you. I am going to share with you. Then you can able to practice from your end also.
Okay.
Guys, let me know if you have
Okay.
any trouble in understanding how to create the Snowflake account or something else. Why I am stopping till here means, at any cost, 100% you need to create account today. While coming to tomorrow session, you have to be ready with your account. So only after completion of the tomorrow session, I am going to share with you all the code, all the things, so that right immediately you can able to do the practice. Next, if you are not creating, if you are unable to create the account, if you are not able to create the account, you are not ready, then you are lacking, and then you are not able to do the practice, and then it is problem for you. So that what I am suggesting you, whatever the queries, whatever the difficulties you face, you need to at any cost create the account and be ready with the for tomorrow's class. That's why I am stopping the session here. Fine, guys.
Okay, sir.
Any difficulties
Okay,
here?
sir. No, sir.
No,
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 right?
sir.
All good.
Yes,
Yes.
all good.
Tomorrow we will meet at same 6 a.m. guys.
Okay, sir. Yeah.
Fine.
Yes.
Yeah.
Sir.
Okay. Then we'll close the session for today.
Yeah.
Okay.
Thank you, sir. Yes.
Thank you. Bye bye.
Bye.
Uh, just as before going to proceed, just let me know if you have any doubts. Jayant, Manohar, Nitesh, Raju, you all guys are in yesterday's part of yesterday's class, right?
Yes, sir.
Yes. Yes, sir.
Just yes, any doubts in understanding of the definition of Snowflake?
Mm, no, sir.
So we have discussed basic level of information yesterday.
Yes.
Any doubts?
No.
Right. No, no,
No.
no.
Okay, super. One second. So we will discuss today uh, architecture of the Snowflake. Architecture of the Snowflake. One second. Guys, actually, we have a three layers in Snowflake architecture. We have 3 layers in Snowflake architecture. One is cloud service layer. Another one is query processing layer. Third one is database storage layer. Let me repeat once again. One is clouds. Guys, just I am suggesting you and recommending you after the each and every session, whatever we are going to discuss, the theoretical part and then code part, I will share you end of the session to all of you to your personal mail IDs. At the same time, just please prepare some running notes from your end also, so that it will be easy to rewind the things. Just make some notes from your end also. Fine.
Sure.
Okay. Yeah. So we have a cloud services layer, and then query processing layer, and then database layer. I am repeating once again. So why I am repeating once again and once again? This Snowflake architecture is very much important. Damn sure you will get one or two questions from the Snowflake architecture in the every interview, wherever you go, in all the companies. That's why I am repeating. So we have a cloud services layer, we have a query processing layer, we have a database storage layer. Now we will discuss one by one. So what is this database storage layer will do? What is this database storage will do? Storage component this is a one of the database storage component. This is one of the component of the Snowflake. Nothing but, so we have a like storage and then compute component like that. This is the storage component of the Snowflake. And so whenever you load the data, into a Snowflake, automatically the data will be stored in a continuous micro partitions. Guys, what is the meaning of this micro partitions means? See, if you have a some 2 TB of 2 TB of CSV file, 2 TB of CSV file in your source system, when you load that 2 TB of CSV file data into a Snowflake data warehouse, automatically that data will be stored in the tables. And then from the tables, in a database storage layer, in storage component, so we have a micro partitions. Where your business data is going to reside into the component. So the least component of the storage layer in the Snowflake is micro partitions. When you store your data in a Snowflake, automatically the data will be stored into a continuous micro partitions. Each micro partitions will be having the size 50 to 500 MB. Fine. So apart from these micro partitions, the data will be stored in the columnar format. Data will be stored. What do you know? What is the meaning of this columnar format? Guys,
Means column format.
yeah, column format is. See, first, let me explain you what is the meaning of the micro partition. How it looks like. See, this is the micro partition structure. I will tell you what is the advantage to have the data in a micro partitions, and also what is the advantage to store the data in a column format. See, if you speak about the traditional database or a data warehouse, data will be stored in a row format. Data will be stored in a row format in our traditional data warehouse or a traditional database. For example, traditional database, if you consider a SQL server, where in a RD SQL server RDBMS or else in a SQL server data warehouse, the data will be stored in the tables in form of columns and rows, and then so the data will be stored in the form of the rows in a traditional database or a traditional data warehouse. In case of a Snowflake, the data will be stored. The data will be stored in a columnar format. I will tell you that one. See here, itself the data. I will tell you. See, this is one of the example. This is the one of the example of the table. So we have a column called type, name, country, date. Type, name, country, date. The data is stored in a. So this is the traditional structure of the table. So data is stored in form of a column, and then rows. See, we have a type column, name column, and then country column, and then date column. When the data is loaded into the Snowflake, the data will be stored in a continuous micro partitions. This is a one micro partition. This is another micro partition. This is another micro partition. This is another micro partition. Within these micro partitions, your table data is going to loaded into multiple micro partitions. If you see here, the column type, name, and then country, date. So this is our traditional structure. In case of your Snowflake, see, the data is storing in a micro partitions in column format. See here, the type is here. Type is one column, and the name is another column. Country is another column. Date is another column. See here, type, name, country, and then date. This is a row format. So this is a column format. So your first record first record type is 2. See here, first record type is 2. Second column, name is A, and then country, first record is UK, and then date, first record is 11/12. So what is the advantage of this having the columnar format means, if you want to search a data, instead of searching a whole rows in a whole columns, just it will traverse only in single direction, instead of checking the all the data from your all micro partitions, so that you can able to retrieve the data in a very faster. As I mentioned earlier, the data will be stored in a micro partitions and compressed way, and then optimal way. So this is what you can able to pull the data very fast from the Snowflake. See here, suppose uh, if you want to search, like type equal to or name equal to y, see, y is available in micro partition 3, and then micro partition 3. So if you write a query, select star from table where name equal to y, so the value from the name column is available in the micro partition 3 and then 4. So what it will do, if you hit a query into the Snowflake data warehouse, instead of searching all the micro partitions, it will go into the particular micro partition in a column format. It will go into the particular micro partitions, and then it will retrieve the data from the from the Snowflake data warehouse for you. So what is the benefit here? Suppose consider for your one table, if you have a n number of micro partitions, the data is table related data is stored in n number of micro partitions. If you are searching for the particular set of the result set, instead of searching the n number of micro partitions, directly it will go into the particular micro partitions, and then it will retrieve the data. So that what is the benefit here? Instead of searching the all the micro partitions, it will go into the particular micro partitions, and then it will retrieve the data, so that you can consume the execution of the time of your SQL code. Then how this Snowflake will know how how this snowflake will know if you write a select star from table where name equal to y, then it will go into the only particular micro partitions. How the snowflake will come to know that the y is available in the micro partition 3 and 4. So we have some metadata table. Suppose when you store a data into a table, automatically the data will be stored into the micro partitions. That micro partitions will be having the for each and every micro partitions will be having the serial numbers for the micro partitions. The serial number and the micro partition details will be written into some metadata tables. There it will mention that this micro partition is having the data from this range, and then from this table. So using that metadata tables, when you query for your table, then it will check the metadata tables, and then so based on that it will identify the which micro partition has the data for your query, and then directly it will go into the particular micro partition, and then it will bring the data for you. So that instead of searching all the micro partitions, instead of searching the n number of micro partitions, directly it will go into the particular micro partition, nothing but micro partition number 3 and then micro partition number 4. So it will save the to search the remaining 2 micro partitions. It will go into the directly 3 and 4 micro partition, and it will bring the data for you. And one more thing is, so as you have a data in column format in Snowflake, instead of searching in your row, see in your, suppose if you start from table where name equal to y, it will come into the name column, and it will traverse all the records, and it will identify the y, and then it will bring the entire record for you guys. So this is and all, it will take the long process to search the data and then return the data. So to overcome all these things in Snowflake, they have designed the architecture in a very simplified manner. So whatever you want, suppose if you want to y, only it will come and then it will search into the only this way, and then it will bring the data for you guys. So this is about the database storage layer in the architecture of Snowflake. So whenever you will, once again I'm repeating, just make a note down somewhere, guys. What is the meaning of micro partitions? What is the meaning of column format? So what is the meaning of this database storage layer? How the data is going to store? So everything you need to know, and then whatever we are discussing here, just if you explain all these things, this is more than enough, guys. See, database layer is one of the component in the Snowflake where you are going to store your business data into your Snowflake. Whenever you load the data from the multiple files from the different sources, obviously the data is going to store in a Snowflake in a tables and in a multiple micro partitions format. Whenever the data is loaded into the micro partitions address and the details will be available in the metadata tables in the Snowflake. So by using that metadata tables, if you query on a particular table by using the address of the metadata, by using the address of the micro partitions which are available in the metadata tables, directly it will go into the particular micro partition, and then it will bring the data for you. So instead of searching the n number of micro partitions, it will go into the particular number of micro partitions, and it will bring the data. So this can be called as a optimal way. So instead of traversing all the things, so directly you are going to the particular things and bring the data, so that you can able to see the robust performance comparing to other data warehouse. So this is about a storage layer discussion, guys. Any doubts here? This is the storage layer. Any doubts here? Yes,
Sir,
I need a yes.
that metadata tables contain all the information about the micropartition, right?
Yes, address of the micro partition, and then so it will be having that address of the micro partition. Yes, correct.
Okay. Yes.
Guys, any other
Here
question?
one more
Because
doubt.
yes,
Sir, in the traditional database Oracle, like we have row IDs and some other things, right?
okay.
So based on that also we'll get the query in the quickly, right? So what is the difference between that row ID and here that address of the metadata table?
Row ID means I didn't get you. May I know your name, please?
Sir, so now if I'll store the data in one row in the Oracle table, it will save with one address, address of the not primary key.
I understand your question. See here, actually, see row ID when you create a index, not only Oracle, whatever the RDBMS, traditional RDBMS, when you store the data in your traditional RDBMS, on top of that, if you create a indexes on the table, then only this row ID concept will come into picture, guy. Actually, see, if you don't create any indexes on the table, then this table can be called as a hash table or a heap table. See, until you create a indexes on the particular table, you will not be able to see the address of the any data in your RDBMS tables. If you create a indexes on that, if you create a indexes on the particular table, so it will create a balanced tree in the database based on that. That is different concept. Again, we need to go to that concept. We need to discuss half an hour on that. But yes, for your question, if you create a index on that, for that particular data pages in your database, so there in RDBMS, whatever we have a micro partitions in the Snowflake, there in RDBMS data pages where the data is going to store. Until you create indexes, your data will not be having the row ID. Fine.
Sir.
Hello.
Yes, sir.
May I know your name? Your name, please.
Raju, sir.
Raju. See, I understand your question. Until we create a indexes on a table in RDBMS, row ID concept will not come. Row ID or key ID. Yes, once you create a indexes on your column or a table, then your row ID will come, and then again that balanced tree concept will start. So that is different again. So here,
Okay.
by default, when you store your data, by default he will maintain address in a metadata instead of searching all the n number of micro partitions, you will go into a particular micro partition. Have you got the differences now?
Yes, sir, I got it.
Clear or not? Still, if you have any confusion,
Clear, sir.
let me know. Clear, huh?
No, no. Clear, sir.
Super. Now next. So we are done with the database storage layer discussion. And then we'll go to the query processing layer. So how does database storage layer is important in your Snowflake? This query processing layer is also very much important. In single word, I can say this query processing layer is virtual compute warehouse. Virtual, guys, I can recommend you to make some running note also. I will share this content after this end of the session. Make some running note also. So this query processing layer is a hardware component which can be called as a virtual compute warehouse. Fine. So how your database storage is a storage component. This is virtual warehouse or query processing layer is also compute component. Compute component అంటే hardware component, the combination of RAM, CPU, motherboard, everything. So this is very much important. This query processing layer or a virtual warehouse component is very much important, because how you are going to store your data into your storage component. This virtual compute warehouse, what it will do, whatever the operations you do in your Snowflake data warehouse, whatever the operation, if you are loading your data, if you are submitting your workloads into your Snowflake, what is the meaning of workloads? Workloads nothing but a number of SQL queries. If the number of users are connecting to your Snowflake and then they are retrieving your data, right? If you are processing a large volume of data, if concurrent users are accessing your Snowflake data, whatever the operations you do, your virtual compute warehouse components are very much required, which are a hardware component in your Snowflake, which are a hardware component in your Snowflake. So whatever you do, data load or the data processing, data retrieval, your hardware resources are required to process your request, to process your request, to process your request. See here, virtual warehouses or hardware resources can create the multiple right. See here, till here you are clear, huh? I will tell you. See, this query processing layer is a virtual warehouse, which is a compute layer, and then this is a hardware resources. This is a hardware resource to your Snowflake. It will be useful, and it will be required to process all the requests for your all your requests in your Snowflake. The requests are either you may be submitting your workloads or queries, or you are accessing a data from the retrieving a data from the Snowflake, or loading the data into Snowflake. To process all this request, your virtual compute warehouses are required, which are a hardware resources. Till here, this is the basic concept of this query processing layer. This is clear or not? So if you clear on this, next I will go into the next points in the query processing layer.
Okay, miss. In the query processing layer, virtual warehouses is the hardware component which
Hardware
process
component.
the request.
See, in your traditional database or a data warehouse, you will be having the CPUs, memories, and then everything, right? Like
Right.
that, this is also a virtual warehouse. Virtual warehouse is a hardware resources in your Snowflake. So just you can't able to see those physical devices, those things and all. This is architecture. I will show you how to create the virtual warehouses, how it looks like. So you need to create virtual warehouse. This is also one of the object, like how you are creating a table. So this virtual warehouse is also one of the object in your Snowflake. You are going to create. You are going to create a virtual warehouses. Fine,
Okay.
guys.
Yes.
So now, so you dedicatedly you can able to create a separate virtual warehouses for the each project or each team. Please make a note down. Dedicatedly you can able to create a virtual compute warehouse, or virtual warehouses for each project and each team separately. So whenever you are going to work with the Snowflake as a particular team or a particular project, you can able to access only your project related virtual compute warehouse, so that there is no dependency between the each and every virtual compute warehouse. You can able to do your tasks very easily, and then you can able to execute the things very fastly, so that you can able to see the result very faster. Okay, fine. And also, see, I told you can create each virtual warehouse for each process to improve the performance and make the independent. These are the independent components. So we have a two types of virtual warehouses: single warehouse and then multi-cluster warehouse. Single warehouse can create with the different sizes. Multi-cluster warehouses can create with minimum and maximum clusters. So with minimum and maximum clusters. Yesterday I told you. So yesterday I told you actually single warehouses will be created with the different sizes, and then multi cluster warehouse can be created with the minimum and maximum number of customer clusters. We will be having the separated discussion on the virtual compute warehouse. So where I am going to show you what are the different sizes are there, how the pricing will be happening, and what is the multi-cluster warehouse, and then what are the options we have, how do we create everything. I am going to show you. We have one separate session on the virtual compute warehouse. We will see more details on, because this is very much important, and then you will get the multiple questions on this virtual compute warehouse also. I am going to take one separate session on the virtual compute warehouse. We will see the in detail details of the component. So for now, So you can able to see, we can able to tell that this query processing layer is a virtual compute warehouse, and then virtual compute warehouse which is a hardware resources to your Snowflake. Guys, any doubt in here? Virtual this query processing layer. Hello,
No, sir.
clear, right?
Yes.
I will share you this content. I will share you this note also once completion of this discussion. So next layer is a cloud services layer. So we are done with the database storage and then query processing layer discussion, right? Agree?
Yes.
Yes,
Hello.
sir.
Yeah. So we have a cloud services layer. What is this cloud services layer? See here. So this is a top layer. This is a very much a top layer, and then it will handle the entire Snowflake, guys. This is the very first layer in your Snowflake architecture. So this is the key component in your Snowflake architecture. It will take care of everything of your Snowflake till when you create a account in your Snowflake. When you create a your Snowflake account, so your username, your password, and your account details will be taken care by your cloud service layer. So all the access control related information will be checked, managed by your cloud service layer. When you log in into Snowflake, when you log in into your Snowflake account, initially your cloud service layer will be cross-verified with your details. Then only it will allow you to log in into your then only allow you to log in into your Snowflake. So without this layer, your Snowflake will not work. So this is a top layer. This is very much important layer. It will take care of your access control related things, and also whatever you store the data into Snowflake, whatever the data is your processing, whatever your workloads are executing or queries are executing, your cloud service layer will be managed, your storage component, and also your virtual compute warehouse also. Everything will be managed by your cloud service layer. See, if you execute one query in your Snowflake, till once you hit the query in your Snowflake data warehouse, till you get the result into the end users, entire thing will be taken care by. What it will do, it will receive the request from the user. Suppose Razu is executing one SQL query in Snowflake. When the Razu is started to execute the SQL query in Snowflake, what this cloud service will cloud service layer will do, it will parse your query. What is the meaning of parse? What is the meaning of parse? Parse nothing but it will check the syntactical thing, and then if everything goes well, then it will send this request will go into the next level. So when you hit the query into your Snowflake, initial layer, cloud service layer will accept your request. It will pass the query, and then it will pass into the next virtual compute warehouse. Layer. There you will be having the cache. Cache nothing but this is one of the memory. Already, if the cache is available, if already cache has the data for for your query in the virtual compute layer, then it will return the data from the cache itself. The cache is don't have in virtual compute warehouse layer, then the request will go into the your storage layer, where the data is going to store in the Snowflake. So from there, the data will be returned into the your cloud service layer. So what I mean to say, cloud service layer will accept the request, and then it will push into the next level, and then it will bring the data, and then it will submit into the end users. So this is the one of the things, and also remaining things it will take care of the infrastructure manager and then metadata manager. I told you metadata, those things and all, whatever the metadata tables will be having, those things and all it will taken care by your cloud service layer. So this is about the cloud service layer, guys. Then now we have discussed database storage, and then query processing, and then database database cloud service layer. Guys, any doubts in this description architecture? Hello?
Good, sir. Good. Yeah.
Good, right?
Yes, good.
Yeah. You can contact the institute. They will share you the material. They will share you whatever whatever we are discussing here. This material, everything the institute people will share you guys. Just contact to the institute guys and then ask for the material, and then they will share you this material, guys. Is that fine? So tomorrow we will be tomorrow we will discuss on the in detail of the virtual compute warehouse, and also how the pricing is the doing, and then what are the different editions are available in the Snowflake. Tomorrow we will continue with that class, guys. Is that fine?
Fine,
Yes,
sir.
sir. Sir, I have one question. Sir, can you practically a small query and how to
Sorry?
store it? Miss, can you give one example how to store the data in the column and what mechanism they use like metadata how data is address is stored in the metadata.
Metadata tables I will give you, but actually when you store your data into a Snowflake, how the data is going to store in the Snowflake, that we can't see. Actually, we can't see that one. Actually, the internally it is happening,
Okay,
but
okay, okay.
we can able to see the metadata, how the data is stored and what is the address. We can able to see the metadata as part of the course. I will give you that metadata tables.
Okay. Sure.
Fine. Any other questions? Any other questions, guys?
Sir, we are loading to files in same like SSIS packages like we are here using.
See, in SSIS package, what you will do, so you will have having the some CSV files in your some shared locations or in some
Yes.
different sources. From that CSV files, initially you will load the data into your staging tables, right? So from
Yes,
there,
sir.
and then on top of that staging tables, you will apply the lot of transformations, or you will write a number of stored procedures on top of your staging tables, and then required data you will load the data into your target tables which are available in the production servers, right? That is the thing happening in your SS package, correct?
Yes, yes.
In Snowflake, what you will do, the advantage of the Snowflake is, instead of loading a data into your staging tables, directly you will load the files into Snowflake. So from there you can able to do a ETL. The
Hello.
uh, that is the advantage. Directly we load the files into Snowflake.
Okay.
So once you load
Okay.
the files into Snowflake, so from there you can able to do the ETL or ELT, whatever you want. So that is the advantage
Okay.
and beauty of your Snowflake. So in case of your on-prem, SQL Server, SSIS, you can't able to load the files. You can load the data from the files, but you can't able to load the files into your SQL Server, right?
Yes.
You got the difference.
Yes, yes. Got
That's what there's a very much beautiful concepts and beautiful advantages are there in the Snowflake case actually. Clear?
Clear. Thank you.
Shall we continue tomorrow?
Yeah,
If
sure,
you have
sir.
any questions, you can ask me, or else we'll continue tomorrow.
Yes, sir.
Yeah. Thank you, guys. We will meet tomorrow.
Okay, sir.
Yeah. Bye.
Bye.
Thank you, sir.
Yeah. Thank you. Bye.
Fine. See, single warehouse the thing, but yeah, it will be having the different sizes, right? will be having the different sizes. So based on the usage and requirement, we can choose the size and create the warehouse. I will show you. So what is all the options. And second one is multi-cluster warehouse. Multi-cluster warehouse is, we have a, see here, 1 second. Multi-cluster warehouse, we have a mode and we have a scaling policy. Mode, scaling policy. This is standard and economy. Standard and economy. See? Standard and economy. So here auto scale and then maximized. Auto scale and maximized. The combination, we can create this multi-cluster warehouse like this combination. Don't get confusion. I will explain all these things. Maximized. Fine. So this is the best practice. Now let me explain one by one. So I am discussing about the first one, auto scale and then standard. If you select the auto scale, see, first of all, what is the meaning of this virtual warehouse? Nothing but this virtual warehouse. Once again, I'm repeating you guys. So the way the virtual, this is the virtual warehouse. How you are going to create a virtual warehouse? See, this is a single virtual warehouse option. You need to provide your virtual warehouse name, and then you have a different sizes. This is a single virtual warehouse. If you come down, you have a option multi-cluster warehouse. If you select this multi-cluster warehouse, you have these many options. I will tell you all these options, and then what's the purpose of these options. First of all, this virtual warehouse is a Snowflake component. So which is the hardware component to your Snowflake? Yesterday already I have explained this, which is a hardware component and which is very much essential, for your all the tasks like data processing, data loading, and data retrieving, and then while submitting a queries to perform all these activities. Your virtual compute warehouse is very much essential. This is a hardware component, purely hardware component. So this is the single virtual warehouse, and then this is multiple. Single virtual warehouse completely you will create a virtual warehouse, and then you will select the different sizes, small, small, medium, large, X large, double X large, and the triple X large, like that. So based on the requirement, you will select the different sizes and create the virtual warehouse. In case of a multi-cluster warehouse, you have two options. You need to make a note down, and you have to remember all these things, guys. You have two options: mode and then scaling policy. In mode, you have two options: auto scale and then maximized. In scaling policy, you have a standard and then economy. So what is the meaning of this auto scale? What is the meaning of this auto scale and then standard? So when you select this option, you will be having the minimum cluster, minimum cluster, maximum clusters. You can give maximum clusters. You can give minimum cluster is 1 and maximum cluster is 5. And then, so this is mode. This is mode auto scale. This is mode auto scale, and then standard. This is scaling policy. So what it will do, if you select this combination, what it will do, suppose if you try to load the data around 10 TB of data into a Snowflake, 10 TB of data load. Data load 10 TB of data. Fine, this is one of the scenario. If you are trying to load a 10 TB of data into your Snowflake, so what it will do, if you select if you create your virtual warehouse with the multi-cluster warehouse, along with the mode as a auto scale and then scaling policy as a standard, and if you select the minimum cluster is 1 and then maximum cluster is 5, what it will do internally, before loading a data, internally it will calculate. So how many clusters are required? Required for this process? First, it will start with the 1. Directly, it will not start with the 5. It will start with the 1, and then it will start loading the data. If the minimum cluster is not sufficient, minimum cluster 1 is not sufficient, and then it will increase the maximum clusters to 2, and then even 2 is also not sufficient, and it will increase to 3, and it will increase to 4, and it will increase to 5, like that. So based on the requirement, based on the workload, based on the data processing, based on the data load, the maximum clusters will be increased. So this is the one case data load. Suppose you are submitting complex SQL code. Around 10. You're submitting 10 complex SQL code to execute the SQL code and then to retrieve the data from the Snowflake. So here also what it will do, so it will calculate internally. So when you submit, suppose the user name called XYZ, he has submitted around 3 queries. The user name ABC, he has submitted 4 queries. Another user has submitted 3 queries. So multi-users are submitted to Snowflake to execute their queries. Totally, we have 10 queries in the queue. So based on the workload, based on the complexity of the SQL code, then it will this internally the multi-cluster warehouse will calculate that how many clusters are required for this 10 queries. Then those many clusters will be increased one by one. If sorry, those clusters are those SQL queries are required maximum number of 5 customers, 5 clusters, then it will increase the 1 by 1 plus 2, 2 plus 1, 3 plus 1, 4 plus 1, like that. So, so based on the workload and then based on the data processing, based on the data load, it will calculate and then it will increase the number of clusters. So you can call it as a clusters or a servers. You can call it as a clusters or a servers. It will provide the hardware resources to your actual process. So overall, what is the meaning of this mode equal to auto scale and then scaling policy equal to standard means? So based on the requirement, the maximum number of customers will be added one by one based on the query or then based on the data. So this is about the auto scale and then standard. This is clear or not, guys? If you clear this, then you will be understand further points. If you don't understand, then I will repeat once again. Tell me, confirm me, guys.
Good,
If you are understand, sorry.
So cluster means the space, no, virtual space, where we data stored, like.
No, not in a virtual. No. Sorry. You see, clusters mean. Suppose I will give you example. Just compare for comparison. This is not in a data storage component. Virtual warehouse. This is a completely your hardware component to your Snowflake. Let's consider. So in your system, you will be having the RAM, right? RAM.
Right. Yes.
Suppose if your 4 GB is if 4 GB RAM is not sufficient, then what you will do?
We will increase the RAM
to 8 GB. And then
yes.
The motherboard CPU capacity is not sufficient. What you will do?
We will increase the capacity of the CPU.
Like that only. So the multi-cluster warehouse or single cluster warehouse, purely hardware component. If your existing warehouse size is not sufficient, then you will increase the next size, like that. This is not a storage hub. This is completely hardware component. I'm repeating again and again. Fine.
Okay. Yeah.
This point is clear or not clear? If this is clear, then I will go with the auto scale and then economy.
Explain about standard.
Your voice is not clear.
Sir, just once again explain this standard concept.
Standard and then auto scale and then standard. Auto scale and then standard.
Scaling policy standard. Only that.
No. Scaling policy standard. This is the like not only a scaling policy standard. The combination of the mode and then scaling policy. It will not come only a standard. So the combination of mode. If you select auto scale, the scaling policy here. I will tell you. That's okay, fine, guys. If you ask me a number of questions also, not a problem. But the thing is, you guys need to understand. See here, the mode. What I said, the mode auto scale. Agree? Mode auto scale. Agree? Say yes or no.
Yes.
And then maximum number of customers, minimum customers. I have selected 1 to 5. Whatever you select. Agree?
Yes.
And then I have selected scaling policy standard. Agree?
Correct.
So you can't select only a standard or you can't select only auto scale. This is a combination. So what is the meaning of this overall? I will tell you in one point. So based on the workload, based on the data load, based on the query processing, based on the data processing, your maximum number of customers, if you define as a maximum number of clusters to 6, so first it will check with the minimum. So it will check whether the workload or a data processing or a data load is sufficient with the one cluster, it will check. If it is not sufficient with the one cluster, it will increase to first it will internally, it will not internally it will increase to 2. If this is not sufficient, internally it will increase to 3. Internally it will increase to 4. Internally it will increase to 5. Internally it will increase to 6. As you have defined as a maximum clusters 6. Is that fine or not?
Okay.
And then even for your queries also, so this is about a auto scale and then standard.
Right.
In case of auto scale and then yeah.
So when we will decide that with the auto we can use the standard or economy maximum.
I will tell you. So I will tell you the differences. So standard, auto scale, and then standard, auto scale, and then economy. Then we will come to know what in which situation we are going to use these things and all. Fine.
And miss the cluster which means 1 to 5 that is automatically increase as per the data load, or we have to increase our means like whenever we have a more number of data.
No. See, while creation of a multi-cluster warehouse, you will define like this: 1 and then 6. You will give the maximum number of clusters. You will give the 6.
Okay.
Fine.
Means defaultly we provide 1 to 6, right? Likewise.
First, you will provide the 1 to 6.
Okay.
What your Snowflake will do based on the requirement, as you have created this maximum number of 6, even though you have provided a maximum number of 6, it will not use the maximum number of 6 customers, because everywhere the costs are involved. If you select the 6, the different size. If it is using the 2, different size. So to save the cost, first it will go with the minimum number of customers. No, minimum number of clusters. Fine.
Right.
So based on your data processing, even though if you select a maximum number of clusters, it will not directly go and then use the maximum number of customers directly. It will start with the one by one. If the things are not sufficient, then it will go to the 6.
Okay.
Is clear or not?
Yes.
Still confusion, huh?
Is internally going to miss 1 by 1, or we have to?
No, internal. No, that's not internal. See, you defined 6 maximum number of customers 6. Okay.
Then
You
internally
define maximum.
data.
No. You have created a virtual warehouse. 1 second.
Right. Yes. And sir, this is you're doing on the app.snowflake.com.
Sorry.
This is you are creating the warehouse in app.snowflake.com, right? Yeah.
No. That I will show you. How do you create account, those things and all. Okay. I will show you how do you create those things and all. Don't confuse with that.
Okay. Miss, my question is only that whenever we define 1 to 6, then
Okay.
as per the data, the Snowflake internally increase the suppose we have 10 TB data, then we will we will use only one virtual warehouse, only one. Then
Sorry?
if it is 0.
See, I have created this multi-cluster warehouse.
Okay.
Fine. Multi-cluster warehouse. Edit. See, you are able to see the sample multi-cluster warehouse, right? Sample multi-cluster warehouse. Just now I have created.
Yes,
Fine.
yes. Yes.
I have created sample multi-cluster warehouse with these many details. What are the details I have given? Just let me know.
1 to 6, 10 and standard. Yeah.
I have given these many options. What is the meaning of this means? Directly it will not use the maximum number of customers. Directly maximum cluster, it will not use the maximum clusters. It will use one by one. If the things are not sufficient, then it will go into the 6. Fine.
Yeah, correct. That is okay. Okay.
Clear or not clear?
Yes, it's clear. Yes.
Now I will go with the one by one. Jayant.
Yes, sir. Clear, sir. Yes.
Jayant. And then Manohar. Manohar. What about Rajesh? Hello.
It's clear, sir, for me.
Right. Raju.
Yes, clear, sir, for me.
Fine. Then we'll go with the other option. So now we have selected standard, which is the auto scale. Now we can go with the economy. Economy. Here also you will select, you will do the same thing. Here also you will select the maximum and then minimum number of clusters like this. What it will do, if you select the economy, in case of a standard, whenever you upload the data or whenever you submitted your complex queries, it will calculate and then it will increase. What this economy will do, suppose if you select a 10 SQL queries to your Snowflake, it will calculate internally if the 10 queries can be completed within the 6 minutes. If the 10 complex queries can be executed within the 6 minutes, then it will go with the existing clusters. If the 10 queries are not sufficient to execute within the 6 minutes, then it will increase the next clusters. I will tell you once again here. So based on the workload, based on the data load, it will increase the next cluster. Here it will wait for the 6 minutes. It will internally calculate by the Snowflake if the queries can be executed within the 6 minutes. Whatever the queries are there in the queue, when you submit, it will be there in the queue in the Snowflake. Whatever the queries are there, whatever the data load size is there, they can able to submit within the 6 minutes, then it will go with the minimum number of cluster number 1. If the things are not able to complete within the 6 minutes, then it will increase the next maximum number of clusters. This is about economy.
Okay.
Guys, clear or not? Tell me.
Yes. Means in this economy, whenever we select the scaling policy and economy, whenever we run the queries, it will wait for 6 minutes approx. After that,
no. Internally, it will not wait. Internally, it will calculate whatever you guys are submitted 10 queries. Internally, it will calculate. Okay. It will consider that I received the 10 queries. I can able to complete these queries within 6 minutes or not. Yes, I am able to complete these queries in 6 minutes. Then it will go with the minimum clusters. If these queries are not able to complete within the 6 minutes, then it will increase with the next maximum number of customers. Clear or not? Tell me.
Okay.
No. Still, if you have any doubts, ask me. Then I will tell you.
Standard is also increasing the cluster and economy is also increasing the cluster. The difference is only that thing. It's
Usually see maximum number of customers. The concept is to increase the clusters based on the requirement. But the thing is, the economy is based on the time, the 6 minutes.
Okay. Right. Yes.
Based on the time 6 minutes. The major funda to declare or define a maximum number of customers to give a more capacity to your hard disk. So here is it will calculate internally whatever the queries are there in the queue. If I am able to complete those in 6 minutes, then I will use existing thing, or else I will increase the maximum number of customers, maximum number of clusters. That is the major difference here. But in real scenarios, we will go with this option only. This is the best practice.
Okay.
This is the best practice. And then what about third option is maximized. I will show you here. See, if you select maximized, there is no minimum and then maximum customers. There is no scaling policy. See here, if you select maximized, you will be having the only cluster option. Select some clusters option. So there is no scaling policy. Maximized means if you define clusters as a 5, please observe the difference and then make a note somewhere. If you define a maximized clusters equal to 5 means when you submit all these things, instead of increasing one by one, all the clusters are used for your data processing parallelly. All the defined clusters are used parallelly to complete your task. This is the major difference. So here, based on the capacity, it will increase in these two options. Based on the workload and capacity, the clusters are increased. Fine. So here in maximize and then clusters, it will be maximize and then clusters. It will be used parallelly. All the clusters at a time. Clear or not? But this is not recommendable. Because if you select very small query also, then it will try to use all the clusters at a time. When you use number of more clusters, then it will charge that amount onto your organization. So whenever you try to use minimum number of clusters and then minimum number of storage component, then it will charge that much of amount only. If you use more storage capacity and then more hardware disk virtual warehouse, then it will cost more on your organization. Clear, guys?
Yes.
This is clear or not? Virtual warehouse or virtual multi-cluster warehouse. Guys? No.
Good, sir.
Okay. So in single virtual warehouse, in clustered virtual warehouse, we have a common options, advanced options. I will tell you. Auto resume. Auto suspend. So this is the common for your single virtual warehouse and multi-cluster warehouse. What is this auto resume? Auto resume yes. Auto suspend yes. So here there is no option yes. You need to select this like this. Yes or no, like this. Fine. See, auto resume is nothing but let's discuss about auto suspend is. What is the meaning? Suppose this is your Snowflake session. Fine. And this is your virtual warehouse. You created recently, right? This one, guys. Sample multi-cluster warehouse recently. Just now we have created this one. So what it will do, auto suspend. If after 10 minutes, if you give it 10 minutes here, auto suspend, yes. After 10 minutes, if you are not using your virtual warehouse, then it will go automatically into suspension mode. It will go automatically into suspension mode. When it is going into suspension mode, then the charges are not applicable. Charges are not applicable, and then you are saving cost to your organization. Fine. So this is the beautiful option actually. If you are working continuously, then it will be in active mode. If you are not working, continuously 10 minutes, then it will go into a suspension mode. And then again, when you restart your session, then it will come into this one, auto resume. Automatically it will resume, and then it will active. So what is the purpose, and then what is the meaning, what is the benefit of this means? See, you are using your Snowflake for continuous 1 hour. So you kept aside your work and then you went outside. So after 10 minutes, so whatever you used for 1 hour, then it will charge for you. Whenever you kept aside and then you went outside, after 10 minutes, automatically it will go into a suspension mode. So at that time, what it will do, it will start to charge on you. Then it is saving cost for you. So that is the beauty of the Snowflake. Whatever you use, you are paying for that only. So if you are not using continuously for 1 week, then it is not going to charge on you. So this is the beauty of your Snowflake. Have you cleared these options, guys, or not?
Yes. Yes.
Yeah. So whatever I have shown you, how do you create a virtual warehouse? This is a, so we will create again, just this is the theoretical part. So this is the syntax to create the virtual warehouse. This is a SQL syntax to create the virtual. We will create one by one. Just this is a theoretical discussion. If you are not clear on this thing, just let me know. If you are clear, then so we will close the session and then we will continue tomorrow with the pricing, how the prices are applicable on your Snowflake when you are using, and then we will see the Snowflake editions by tomorrow. If you are clear, then okay. If you are not clear, just ask me. Then we will discuss all these things. These and all very much important concepts. You need to understand. You need to make a note. You need to remember. You will get a questions, interview questions on also on this concepts. Guys, clear or not? Hello.
Clear. Clear, sir.
Yeah, clear.
Okay, super. If you have any doubts, you can ask me so that we can discuss.
Today only I joined first time. Previous classes, how many classes, sir, previously happened?
May I know your name?
My name is Rajesh Kumar.
Rajesh. That's fine, Rajesh. Whatever happened in previous class, then I will try to provide you the things. Just whatever we have discussed, theoretical things we have discussed. Continue with that.
Yeah.
Then whenever I get a time, then I will let you know all these things. Okay?
Yes, sir. Yeah, okay, sir.
So we have started with the basics and then the theoretical part. We have not started any like practical things. Just continue with this. Then we will proceed. No, not a problem.
The duration, how many days, sir?
35 classes, Rajesh.
Okay.
Guys, any doubts?
No, sir.
Shall we close the session and continue tomorrow, same time?
Okay, sir.
Fine. Thank you, guys. We will meet tomorrow.
Yeah.
Okay, sir. Thank you.
Bye.
Yes.
So you need to contact the institute for the notes.
Okay.
They will give you.
Okay. Fine. Yes.
Thanks.
Bye.
Thank you.
virtual warehouse will be charged based on the credits. Nothing what? They will measure the charge or cost. So based on the number of credits you use, suppose if you use X small, virtual warehouse, so for 1 hour they will allocate you 1 credit. For 1 credit, how much they need to pay? How much they need to charge? They will see for 1 credit, $2.7, $4 for different edition, $5.4 into another edition. Suppose if you use large, for 1 hour they are going to consider 8 credits. 8 credits into $2.7 for this edition. 8 credits into $4 for this edition. 5.4 into 8 credits for this edition. So based on that, they are going to charge you guys. Have you clear about this virtual warehouse calculation or not? Tell me.
Yes.
Confirm me, everyone. Confirm me, everyone. If you
Yes.
clear, then I will proceed further.
Yes.
Clear,
Yes,
right? So this is about the hardware component usage calculation. What about the storage? See, if you have taken Snowflake subscription. Suppose let's consider this is the January month. So your organization has assumed that the business is going to start from the January, but unfortunately the business got delayed. Already you have taken the subscription, but you are not using. In such case, you need to pay $25 per month if you are not using anything, but you have taken a subscription. And or if you have taken the subscription and you have started to use your Snowflake. In this case, for 1 TB you need $2. For 1 TB you need to pay $40 per month. If you use 100 TB, 100 into $40 per month you need to pay. So the cost will be in two ways actually. You need to pay for the storage and you need to pay for the compute virtual warehouse. So this is the way they are going to charge you guys. Is this clear or not? So this is minimum $25 you need to pay if you are not using. Suppose if you are using, you started to load the data, so you need to pay $40 per TB. If you use 500 GB, then it will be divided into that part. So like that it will go. So this is about the pricing details on your hardware resources and your storage component. Clear or not?
Yes.
Yeah. So these are the different virtual warehouse sizes. So these are the credits. These credits are very much important. So based on these credits, they have already defined. Boss, if you created your virtual warehouse with the medium size, so in this case, we are going to allocate you 4 credits per hour and then 4 into, so based on the edition, and then the $2.7 like that they are going to charge you. So this is very much important. You have to understand what is the different size of warehouse sizes and what are the credits, how they are going to start pricing on you. So this is about the pricing. Pricing. If you have any doubts in the understanding on the pricing, just let me know. We will discuss and then we will proceed further. If you are clear, just confirm me. Then we will discuss next topics. And also, always I am trying to tell you, please make a note somewhere as a running note. Sure.
Yes, sir.
Guys, clear or not clear?
Yes, sir.
Okay, fine. Then we'll go to discuss the different editions are available in the Snowflake. Different editions. We have 4 editions actually: standard, enterprise, business critical, virtual private. So I'm repeating once again. So you need to make a note also. So we have a standard edition, we have an enterprise edition, we have a business critical edition, we have a virtual private edition. So these are the 4 types of editions we have in Snowflake. In general, or in projects, we are using this business critical. We are using this business critical edition for our business purpose. We are using this business critical for our business purpose in our companies. Then we'll see what are the options are available. What are the different benefits or great features are available in the each editions. The standard is very basic edition. Very basic edition. Here, whatever the data is you are going to store, that is in a encryption format. Time travel is up to 1 day. Now, the time travel is one of the great feature in Snowflake. What is the meaning of the time travel? Time travel means, suppose already I have explained in very first class, but let me repeat that one. Time travel nothing but if the data is modified from the table. So after modification of the data from the table, so you came to know that. So this is not the whatever you have done the modification, then that is not that is not a good modification. You need to restore the original data into your table. So in such scenario, in Snowflake has provided you an option, the time travel option. Nothing but you can go back to the history of the table, and then you can bring the original data and restore the original data to table. So in the standard edition, this history will be available for only 1 day. So suppose if you done the modification to the table today 6 o'clock, till tomorrow 6 o'clock you can able to go to the history of the table and then bring the original data and then restore the data. It will available for only 1 day. If you cross that 1 day, then it is not possible. And then what about the disaster recovery? Disaster recovery nothing but suppose if databases go offline, then you can able to bring that into online. What about this data share? Data share nothing but a secure data share. So you can able to share the data between the Snowflake accounts. This is about your standard edition. Coming to the enterprise edition, whatever the features are available in the standard, that will be available. That is very basic. Second one is multi-cluster warehouse. Yesterday we have discussed single warehouse and then multi-cluster warehouse. In standard edition only you can work with a single warehouse. This enterprise edition will be supporting the multi-cluster warehouse also. This time travel in enterprise edition will be there for 90 days. In case of standard, time travel will be available only 1 day. In case of enterprise, time travel option will be around till 90 days. So this is a great feature actually. So suppose 90 days means if you have done your modifications today, till 90 days, if you want to bring the data, then it will be available for the 90 days. So within the time, anytime you can able to go back to the history of the table and then bring the data. And then next, what is this materialized views? Materialized views, one of the concept in Snowflake which is used to improve your improve the performance of your SQL query. Suppose your select statement is taking around 5 seconds to return the data. On top of that, if you create a materialized view, then you can able to bring the data in within 1 second. The beauty of this materialized view is it will improve the performance of your SQL query. It will improve the performance of your SQL query, where your SQL query is taking 1 minute, but your materialized view will give the result within a fraction of seconds. That is the great feature of great benefit of your materialized view. Search optimization, column level security, these things are provided in enterprise option. In business critical, so whatever the features are available in the enterprise edition, by default that will be there. Additionally, all the objects, all the things are encrypted everywhere. All the options, whatever you are going to create the objects, those are encrypted everywhere in the internally. We can't see those encryption and all, but internally it is happening. Internally it is happening. So that is a great feature. What already enterprise edition has the so many features. Those features are available with the business critical plus this data encryption everywhere, and then failover and then disaster recovery. So failover and then disaster recovery, nothing but if your database is crash, and then you can able to bring that database into online. So this is the great feature in the business critical edition. What about the virtual private? All business critical features are available in the virtual private, and then the extra is you need to create a separate environment, separate servers for different environments. Suppose if you are maintaining QA server, if you are maintaining testing server, if you are maintaining dev server, if you are maintaining production server, so for that you need to create a separate servers in your virtual private. So this is about your Snowflake editions, guys. Any doubts in this? These are some theoretical parts. You will get the interview questions. What are the different types of editions are available in Snowflake, and explain them. And also you will get the what is warehouse, what is multi-clustering warehouse, and what is the Snowflake architecture, how many layers are there, what are the functionality of those architecture. Can you explain all those things? These are the theoretical concepts. So you have to, for sure, you have to remember, understand, and explain thoroughly. Whatever we are discussing in the sessions, if you understand that and explain it clearly, whatever we have discussed here, that is 100%, 1000% more than enough, guys. That's why I am asking you. I will share you the note. Along with me. You also prepare your some points in your notes, so that you will check the material and then you will check the note, so you will become a comfortable. If you get any doubts, again you will come back to me and we will discuss on the same topic, so that you will become a comfortable. So this is about the editions, guy. Any doubts, let me know. Just open your mouth, guys.
No, sir, but I wanted to know, in a typical real-time environment or a real-time project, typically a dev or QA or a production environment, what are the additions might be there? I mean, will be there. Whether the dev will be having only standard edition, or whether the QA having enterprise edition only, or the production might.
Usually in our real scenarios in our organization, we all are using business critical for all the requirements.
Okay.
Next question. If you don't have any questions, then we'll move into another topic to discuss.
No, sir. Understood.
Fine.
Yeah, then we'll go how to connect to Snowflake. Web user interface. Second one is NoSQL through the DOS command. Through the DOS command. So we can able to connect your Snowflake. You can able to connect your Snowflake using your web user interface or using Snowflake or use NoSQL using DOS command. And also apart from this, we have some other options also, but majorly we are using these two options only. Some other options also available, JDBC drivers, ODBC drivers, those things and all. But in real time scenarios, as per my experience, we have used only these two options. Only these two options. Then, as part of our regular classes, daily we are using this web user interfaces, this NoSQL and then DOS command things. We will be having the one session how do we use this NoSQL. Then now we'll see how to create the Snowflake account. How to create the Snowflake account. Fine. You need to follow the steps and create yourself. And then we'll explore what are the options are available in your Snowflake account. Then go to Google. So here make a note somewhere. Snowflake.com. Snowflake.com. Guys, have you make a note? Snowflake.com.
Yes.
I need confirmation from all, because you need to create account from your end. This is the free account. This is a free account. It will be available for the 1 month. You can practice in that environment. You need to create. You can create, which is very easy step. You can create from your end also. Just you need to follow what I am doing, right? Just this is snowflake.com. Enter the snowflake.com. Then you will get into this home page. Click on the start for free. Click on the start for free. So here, provide your all the details. First name, I will give the Durga Soft. Email ID, I will give my email ID. It will go into that. I will give the company name as Durga Soft. Role you need to select consultant. Location you need to select as a India. Guys, are you following or not?
Yes.
Yes.
So you need to give your personal details here. So once you have given everything, just continue. Click on the continue. See here, you need to select edition, standard or enterprise or business critical. I am selecting a business critical. You need to make a note down. You need to select a business critical option. This is the option to select the edition. Once you select the business critical, this is the option to select the cloud provider. You need to select the AWS. Guys, you are following or not?
Yes,
This
yes.
funds.
Yeah.
Super. So you need to select the AWS. See here, it is asking continental information. So as we have selected India, just select this Asia Pacific, Singapore. Then click on the get started. Click on the get started. Click on the get started. Now it will ask this many options. You can skip this one. You can skip this one. You can skip this one. See, now you are now signed up. An email to activate your account has been sent to your email ID. I will log in into my email ID. There you will get one link to activate the account. Snowflake.com. Activate your Snowflake account. Click on this. Click to activate. Click to activate. Then it will navigate to this page. Now give the username and then password. So this is the key here. You need to make a note this username and then password. I will give the Durga Soft user 11. One second. So you need to give the username and you need to give the password and confirm password and then get started. So this is your home page of this is your home page of your Snowflake account. You need to make a note down like this. This is your account URL. This is username. This is password for your account. You need to save somewhere so that you can able to log in daily and then work. So this is the your when you create an account, then you will get this page at very first. Have you make a note down all the steps, guys?
Yes, yes, sir.
See, when you get here this option, first option is worksheets. If you click on this worksheet, see here, you will have a plus worksheet. If you click on this, so from this option, from here you can able to query your SQL queries in this area. So this is one of the option. So worksheets where you are going to write your SQL queries. Next, data. So here you can able to create the database. Fine.
Yes.
So here if you want to create any new database, you can able to create new database. If you want to create any schemas, then you can able to create the new schemas from here. Like that. See, first one is worksheets is important, data is important, and then this. In admin, here we have warehouse option. Here you need to create your warehouse. So these are the three options you have to understand. So once go into your worksheet, then click on this latest one. So here you can able to create your own database. Create database sample database. So here you can able to see your sample database like that. So for now, just whatever we have followed the steps, you create from your end and then start exploring on the things. Whatever you can able to explore, you can explore, and whatever you need to understand, you can understand. So from tomorrow onwards, we will start using the coding and then the actual Snowflake uh, practical sessions. But before that, you need to create an account and be ready with, align with me, so that whatever we are going to discuss in the session, as a theoretical part and then coding part, I am going to share with you. I am going to share with you. Then you can able to practice from your end also.
Okay.
Guys, let me know if you have
Okay.
any trouble in understanding how to create the Snowflake account or something else. Why I am stopping till here means, at any cost, 100% you need to create account today. While coming to tomorrow session, you have to be ready with your account. So only after completion of the tomorrow session, I am going to share with you all the code, all the things, so that right immediately you can able to do the practice. Next, if you are not creating, if you are unable to create the account, if you are not able to create the account, you are not ready, then you are lacking, and then you are not able to do the practice, and then it is problem for you. So that what I am suggesting you, whatever the queries, whatever the difficulties you face, you need to at any cost create the account and be ready with the for tomorrow's class. That's why I am stopping the session here. Fine, guys.
Okay, sir.
Any difficulties
Okay,
here?
sir. No, sir.
No,
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 right?
sir.
All good.
Yes,
Yes.
all good.
Tomorrow we will meet at same 6 a.m. guys.
Okay, sir. Yeah.
Fine.
Yes.
Yeah.
Okay. Then we'll close the session for today.
Yeah.
Okay.
Thank you. Yes.
Thank you. Bye bye.
Uh,
Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
yes, sir.
Right, thank you. So in the last yesterday session, right, just I was briefing you about what is PySpark, why PySpark, right? So yes. So what is Apache Spark for big data analysis for processing and computation, right? If you see more on this, Spark was developed, the personality who developed, right? Spark was developed by Matei Zaharia, right? in AMP lab. It was open sourced. Spark was open sourced, right? In the year 2010, Spark was open sourced in the year 2010. It was donated to Apache Software Foundation, right? It was donated to, yes, it was donated to Apache Software Foundation. In the year 2013, right? In the year 2013. So it was developed, it was open sourced in the year 2010, and it was donated to Apache Software Foundation in the year 2010, used for big data analysis and processing and computation, right? Used for big data analysis, processing and computation. Why PySpark? As I was discussing, like why PySpark. So before that, why PySpark, right? Why PySpark? Yes. Yes. I defining Spark, right? If I want to define Spark, defining Spark. Yes. I define Spark in 4 lines, right? So 4 to 5 lines. Yes. Spark is a open sourced. Yes. Sorry, there was a connection problem, right? Fine. Now, is my voice clear and audible to all, right? Yeah, can everyone please confirm once again? Is my voice clear? Fine. So Spark, I define Spark in 4. Yeah, it's an open source distributed execution framework, right? Distributed execution framework cluster computed in-memory computation with parallel process style. With parallel process style. For large scale data processing. For large scale data processing, right? Yes. So here Spark is an open source distributed execution framework cluster computed with in-memory computation feature and with process style, parallel process style for large scale data processing. Large scale data processing, right? Yes. Okay. So Spark can be coded with different languages. Spark can be coded with Scala by default. Actually, Scala by default. But as compared to Scala, right, today like Python has got many libraries, many built-in libraries, right? Even for, especially for graph algorithms, machine learning, these techniques, right? And for recursive algorithms. So that's why Python also mostly used, both the Python and Scala are mostly used, right? Right. And Java also can be used. So multi-language support, Spark is a multi-language support. It can be coded with Scala, Python, Java, and R language. Like R language also, right? Yes. Spark can be coded with Scala, Python, Java, and R language. And if you say why PySpark, right? Yes. It is the Python API, right? It's a Python API to use Spark. So why PySpark means PySpark is the Python API to use Spark. Sorry. So what is PySpark? Is a lightning fast technology. It's a lightning fast technology. Yeah, that is designed right for fast computing. Designed for fast computing, right? Yes. Is the lightning fast technology that is designed for fast computations, right? I can say like PySpark is a demanding tool. It is a demanding tool among the data engineers, right? Among the data engineers to work with bigger data sets. Okay.
Sir, will you share this notepad with us?
Yes, that's why I'm preparing notes parallelly, right? So no, okay. This everything I'll be forwarding. PySpark is the Python API to use Spark. It's a lightning fast technology that is designed for fast computing. It's a demanding tool among the data engineers to work with bigger data sets. So next, okay. PySpark used for what? So PySpark used for, yes, distributed SQL, creating data pipelines, ingesting data into database, running ML algorithms, graph data streams, right? Yes. So yes. So using we can also write a data into data. I can create a database table. So from a data frame. So Spark data frame is there. The Spark data frame I can write into a database. So a table gets created. I can read the data from database directly. Spark can read data from database directly without the use of any scoop like. And directly Spark can write into the database. And Spark can integrate with any databases like Spark can integrate with Hive, Spark can integrate with database like MySQL or any other, and Spark can integrate with Hive and NoSQL databases. Creating data, I said Spark is a data flow language, right? So collection of pipes. At each pipe, either transformation, filterings, groupings, aggregations, or sorting you are going to see, right? Yes. So if you see the various, okay, we have got some PySpark mini packages available, right? Yes, as compared with the Scala, right? PySpark packages. just PySpark itself is a package, and within that we see like sub package PySpark.sql for SQL operations, for data frame creations, many SQL functions it supports, right? And even PySpark is supporting many modules, right? Many modules and functionalities, even for streaming, right? Even for streaming, if you see like a Spark streaming, micro batching, right? Quick results. I want quick results, right? For every 2 seconds, I want some updates. For every 5 seconds, I want updates, right? Yes. And also not only for that, even like Python is mostly chosen, right? Where Python itself has got many modules. Python itself has got many modules, right? For machine learning, like if you see like Pandas, Matplotlib, NumPy, Pond, CP, Scikit-learn. But still PySpark has got, right, PySpark.ml. That's got many modules and functionalities, right? And even PySpark.mllib, right? Yes. Okay. So if you say like Spark plus Python, so Spark is once again I'm saying Spark is an execution model plus implemented by using a language called Python. Spark and Python combined is a like PySpark. Execution model implemented by using a language called Python. Not only multi-language support. So generally, yes, we have got HDFS. So generally, okay, just I'll show you this, right? So this is your HDFS, we say. Hadoop distributed file system. We say like big data Hadoop, right? Hadoop has got HDFS. So Hadoop is meant for two things: storage and processing. Storage and processing, right? Yes. For storage, it doesn't use any database, right? Because databases has got some drawbacks. Databases has got some drawbacks. Means limited storage databases. Most of the databases, no parallel processing. If volume keeps on increasing, right? Means if you see, if you want the total amount to be calculated for 10 records or 1,000 records or 10 lakh or 1 crore, if data volume increasing, speed decreases, right? And mostly like we talk about the databases can handle only structured data. So despite of all this, it's not going with the databases for storing its data. It's going with a file system called Hadoop distributed file system. Hadoop is meant for two things: storage and processing. For storage, we go for HDFS, not any database, because I was just saying like you have got some drawbacks with it. So despite of this drawback, still Hadoop doesn't goes with database. It's going with a file system called Hadoop distributed file system. And also for processing, Hadoop used to use MapReduce. MapReduce was widely used. If you see from, if you go back like in the year 2012, 13, 14, 15, 16, right? MapReduce was widely used, but now MapReduce is got outdated because of this huge codings and many lot of programming required for this. So it was, so we are using Spark. So for storage and processing, and for storage HDFS, and for processing, now we are going with Spark execution model, right? We are going with Spark execution model. Spark has got very high speed, right? Spark has got very high speed processing. So ubiquitation, right? Storage happening within the memory and processing also within the memory, because of which we are going to get huge, very high speed. So Spark, again, implementation. Spark has got implementation using coding, coded with multiple languages. I was saying like Python, Scala, Java and or language. So, but Java is never preferred. Only some less companies like only some companies, only like couple of 1 or 2 companies, right? They'll be preferring for Java, but our language is never used. Okay. Python and Scala is mostly used. By default, Spark built by using Scala, right? So Java means I was saying some companies like Value Labs or a couple of companies, 1 or 2 companies only using Java Spark with Java implementation. We see like huge codings here, but Scala mostly preferred, Python mostly preferred. But nowadays Python is mostly used, right? That's got for especially for ML, if for ML techniques, ML algorithms for implementations, right? Where PySpark providing many built-in functionalities. Even Python itself has got many modules, right? So total, if you talk about ML, machine learning or data science, total implementation goes in Python, right? Yes. So from different databases, OLTP, online transactional processing, think database, database 1, database 2, database 3, think branch 1, branch 2, branch 3, 3 databases. From this, you are going to pull the data. You are going to pull the data from these different data sources, different OLTPs, online transactional processing. Generally, how to pull the data? You use a component called scoop import. Scoop import, right? Scoop import. Scoop is nothing but SQL plus Hadoop. Scoop import. Into HDFS, you are going to bring the data. You are going to bring the data from different sources to Hadoop. From Hadoop, from HDFS, right? You have many processing components. Previously, MapReduce, Pig, Hive, or they used to take. Now, from this HDFS, your Spark is going to read the data. Spark is going to read the data from this, read the file, and it is going to process it. Process. And again, after processing, again, it can store the data into HDFS. After the result again can be stored in HDFS. Again, from HDFS, you can move that result back to the databases, to the websites. So again, okay, your data is moved to the databases. Otherwise, even I was saying, right? Spark can directly, no need of, okay, Spark can directly read data from this database and write data to database. It can read, it can write directly without the use of scoop also. Without scoop also, directly Spark can read that entire table and it reads the table. This is your database table. This is your database table, right? Table. This table, Spark reads and creates a data frame. It creates a data frame. Data frame is also a structured one, right? With rows and columns. Yes. Again, this data frame, if you want, it reads, Spark reads. And again, this data frame, if you want to write into database, you can write this data frame, you can write and save into the database table. So this both you can perform all this, right, using Spark. So Spark plus Python, Spark and Python combined, we say like PySpark. And I was just saying like Python and Scala, which are mostly preferred. What is the differences we see means? So Python is dynamic typed in the sense variables that what we are creating, variables x equal to 10, y equal to 4.5. Like C language, like Java, we no need to say int x float y. What value are assigning? Integer. So integer variable creates. What value you are assigning to it? Float variable. Float variable getting created. Z equal to a list 10, 20, 30, a list of values. What type of variable Z is? List type. How it is list? Because you are assigning a list to it. So based on that, what value you are assigning to this Based on that, the variables created dynamically, it's dynamic typed. Scalar is static typed. And we talk like Python has a huge community, right? It has got huge community. It is small community, is smaller. So we say like Python software foundation, Python software foundation, right? And Python contains powerful libraries, right? For machine learning, graph and iterative algorithms, less as compared with Python. And if you talk about the PySpark features, main PySpark features, right? In-memory computation, PySpark features in-memory computation. So within the memory level, we can just load and we can just process within the memory, right? That's why we call it as in-memory computation. And lazy evaluation, right? I was saying lazy evaluated is best suited for Spark, which is lazy evolution or active evolution, which is good. Lazy evolution. Lazy evolution means on required, you are going to execute. When required only, you will execute. Means on demand, by performing an action, we execute the entire flow. Spark is a data flow language. Spark is a data flow. So the entire data flow gets executed only when you trigger an action. Until then, it won't execute. Just like a normal function. When you call the function only, it executes. If you're not making a call, when you make a call, at that point only it executes. Any number of times it can execute. Here also, we need to compulsory trigger an action to execute a Spark data flow. Fault tolerant. I said like Spark data objects are divided into multiple partitions stored across multiple RAMs of multiple slaves. If you talk about the Hadoop, it's stored within the disk level, right? But in Spark, what the data is storing means disk processing compared with memory, right? RAM processing has got very high speed, right? Fine. So already Hadoop has got very high speed as compared with the other technologies, right? Still, but Spark has got because of in-memory computation. But during the processing, as Spark processing happening on within the cluster level with multiple machines, right? The data is distributed across multiple machines and is processed parallelly. During this process, as they are machines, if any one slave goes down, right, then Spark has got powerful fault tolerant mechanism, right? It can rebuild. There won't be any data loss and there won't be any failure, job failure, right? So that I'll be discussing in brief about the fault tolerance, how Spark is able to rebuild the data and how it is recomputing, right? Yes. And persisting.
Sir, HDFS means storing the data at disk level.
HDFS, yes, HDFS, right? Hadoop distributed file system. See, every node in your cluster, see every node, okay, 1 second. So one more thing, Hadoop or Spark, what we discussed, right? So it is not for client server architecture. I'm coming to your query only. It is not a client server. It's not for clients. It is not for request response. It is not for request response. It's not for online applications. It is not for online processing. So first thing what you need to understand, Hadoop or Spark is not for online processing or online applications. See, there are two types of applications, online and batch applications. Online applications or batch applications. Online applications means user interactive applications. User interactive applications means user gives the input here. Until the here batch applications means user non-interactive. User non-interactive applications. User doesn't give any input here. These are the applications which runs in the background. So here where you see millions and trillions of data, where records, for example, right, millions and trillions of records, credit card statements for millions of customers. Here user doesn't give any input. If you're making a single online transaction, right, you are going to give the input from source account to destination account compulsory. Without that, the online transaction, booking a movie ticket also, right, user interaction required. But here for batch applications, yes, user non-interactive, right? So if a mobile bill statement generation, credit card statements generation, for example, allocating a railway ticket means your waiting state is 200 or 150 or 100, right? Here user is not performing anything. It's happening in an automated fashion. So batch applications where we see millions and trillions of records. Online for a single transaction, 2 transactions, we won't go for this Spark or Hadoop, where we involve a lot of records. And that too, whenever a user gives a request, immediately it's not for request response. It is for master slave. It is what? Master slave. So where we see a master and multiple slaves. Slave 1, system 1, system 2, system 3, or slave 1, slave 2, slave 3. Means your data object, Spark data object, your data is going to be divided into multiple partitions. You think it's a bigger data object. This data object, assume your system 1 TB, 1 TB, 1 TB is your capacity. So this, if you think you have got a data object of 2 TB which cannot be accommodated in it to any of this, so data will be divided into partitions. Data divided into partitions. Data divided into partitions, and these partitions are going to be stored across multiple systems. They're going to be stored across multiple systems. Okay. Okay, so here data is divided into partitions. Partitions are stored across, not in the disk level, in the RAM level, memory level, right? Data is stored within the memory, within the RAM, and are processed parallelly. So the difference in Hadoop, you see like disk processing stored within the disk. That is, so every node, every system, this is master node and this is slave node. Yes, I'm coming to this. You are asked to your query. So every node will have local file system, Linux, and Hadoop distributed file system. Local file system, Hadoop distributed file system. Local file system and Hadoop distributed file system. Hadoop distributed file system, right? Where you won't see any data, you cannot create a file in HDFS. Hadoop distributed file system where you cannot create a file, there is no file editors. You are going to bring the data or pull the data from different data sources into HDFS. You are bringing the data from different, okay. And the data splitted into multiple partitions and distributed and processed parallelly, because of which very high speed memory level processing, right? Yes. Distributed, I said. Persistence means there's one more feature. Persistence feature means transformation. Again and again, you cannot re-execute the same transformation again and again. The same executed transformation itself, no need to re-execute. We can persist it. Okay, about this persistence, I'll provide you multiple examples to make you understand. One thing you can remember is transformations cannot be reused in the case of Hadoop or other things, but here in Spark, you can reuse the transformations. No need to write again and again. No need to write again and again. Distributed, Spark is distributed, right? Distributed RAM you are going to see. See, for example, there are 10 RAMs are there. Each RAM capacity 8 GB. Total RAM capacity how much? There are 10 systems. Each system has got RAM of 8 GB. Total RAM capacity, distributed RAM
80 GB.
means it can accommodate 80 GB file, right? We can accommodate 80 GB file into the RAM. Okay. So I'll just say, and one more thing you need to understand, you may get multiple queries when I say, right, data is stored within the RAMs and processed within the RAMs. How can, okay, I'll just come back to this Spark data storage and processing, right? Yes, and parallel processing.
Sir, if you don't mind, in future are providing any definition about these features, sir? In memory, lazy, fault, this, sir?
Yeah, multiple examples.
Not examples, sir. Definition of these features.
In memory computation means what? In memory computation means data storage and data processing happening within the memory level. Observe here. Okay. In memory computation is nothing but storage and processing happening. Okay.
That's why I'm asking, sir. Because you are learning
storage and processing happening within the memory level, So these things just we'll be discussing in these features in brief again. Yes.
Yeah, that one okay, sir. Single definition is important for
storage and processing happening within the memory level.
Yeah, thank you, sir. What about lazy, sir?
Within the memory level. Within the memory level is nothing but RAM level, right?
Yeah.
Lazy evolution. Lazy evolution means the data flow won't execute. The data flow, Spark is a data flow. Data flow means, see, observe this. For example, this is your data object. D1 is your data object. This has got some 1 lakh records. Assume. From this D1, I'll apply some transformation. Filtering operations I'll apply. I'll apply some filter operation. The result what you get is D2. D2 has got how many records? Some 50,000, 50K records only, because some records got filtered. On this D2, again, I'll perform some transformation where modifying or some transformation you will apply. You will get some D3. From D3 again D4, some filtering, mapping, grouping, aggregating, sorting. Some operation you perform on each one, right? This is your entire data flow, we say. In the data flow, first your data object, if some filtering, next some mapping, some grouping, some sorting, some aggregations you will apply. This data flow, finally the default result, the final result D4 should be collected, right? So to collect it, the data flow won't execute immediately. Whenever you define this, they are not going to get executed until you trigger some action, D4 dot action. Whenever you apply D4 dot action means from the root onwards up to this D4, it executes and gives the result which can be collected, right? Means whenever you perform action only, the flow is executing. Okay, fine. That we call it as lazy. The data flow gets executed. The data flow gets executed only. So the data flow gets executed only when we perform an action. So we have got different types of actions. Wait, later I'll brief you. Means lazy evaluation means, for example, lazy evaluation, active evaluation means for example, if you are writing notes, daily you are attending sessions, you are writing notes. Immediately you won't read, right? For example, if you are reading, it's active evaluated. Means only when exam is kept, then you are reading, means it is lazy evaluated. Only when exam kept only you read. If no exam, you won't read, for example. Means it is lazy evaluated. Here also, Spark data flow, you are defining the data flow. entire data flow. But when you perform an action only, it executes. Otherwise, it won't. That is what lazy evaluated. Just like one more example, like I was talking about the function. If you talk about a function, right? If you define a function, it won't execute until you make a function call. If you make a function call, then it executes. That is what lazy evaluation. Fault tolerant. Multiple tasks executed by multiple slaves. Slaves means systems. If anyone slave fails, if anyone slave goes down, if anyone slave goes down, fails, then that task will be allocated to other slave. If I give a labor example to make you understand, right? So for example, if you take any education, for example, a college, so daily you will be having some periods, right? Some 5, 6 or 7. You can see like 5 to 6 lectures happening. So 6 faculties taking the sessions. If any faculty is absent, right? During the absence, some other faculty will replace that session, right? Means in the same way here, if during the processing, if any one slave goes down, means if any system fails, right, immediately that task should be allocated to other slave, or even there should not be any data loss where Spark is going to recompute. So we have got a lot of discussion on this fault tolerant. Means the task gets, if any system fails, then immediately the task need to be assigned to other slave. Persistence means any transformation that can be in Spark. We have got a feature, right? Spark any transformation can be reused. Transformation can be reused, right? So to make you understand this persistence and lazy evolution, right? Yes. So I'll just lazy evolution and persistence to make you understand, right? Just I'll give an example, right? So later I need to discuss these things later, but so Spark objects, Spark data objects, we call them as RTD. We call it an RTD, resilient distributed data set. Resilient distributed data set. So Spark data objects, we call it as resilient distributed data set. Okay.
Sir, we can use Spark for interactive queries also, right?
Yeah, interactive queries also, SQL queries. Spark SQL, so separately we got a component Spark SQL, right? Spark SQL component.
Sir, but you mentioned that we cannot use Spark for interactive.
Where?
In the previous paint pick.
For interactive, yes, Spark can be used for all purpose. Previous one.
Yeah. Not here.
Online versus batch. You were saying online transactions versus batch in that example.
Yes, sir. I think that point.
Okay.
No, I mentioned it's not a client-based interaction, right? So that's what he's asking the question, I think.
So yes.
Yeah. That's same thing.
Yeah. Hadoop is not for online processing, right? Online processing. Yes.
Right.
Hadoop is not for, yes, Hadoop is not for online processing. So so if you want to Hadoop or see what is it, big data, Spark and Hadoop is not for online. See for one record or two records, for one record or two records we cannot go. But if you want, see for example, if you got some bigger data object, whether it is structured or unstructured, first you will bring it, you will process it, and finally you can create some tabular structured format. Unstructured to structure, I'll make it, and I'll make a table structure. The table structure, I can perform some kind of querying also can be done. SQL querying, structured query language, right? SQL querying also I can perform on this. So interactive queries, you can interact with this, right? With any queries, right? You can make the data. So if you have got Spark has got a component Spark SQL, so where we see data frames. Data frames are widely used, mostly used, right? We create a data frames. Many data frame APIs available. Otherwise, data frame you can register as a temporary table, and you can perform many querying, interactive queries, right? Spark is designed for interactive queries. Interactive queries is different, and this online processing is different. So on whenever, okay, a single transaction, right, or two transactions, three transactions, right? So it's not, see this Hadoop or Spark is bad for small data, good for huge data. These are for huge data, right? Huge data objects, good for huge data. Means a simple example I say, means here your data is going to be divided into multiple partitions. The partitions stored across multiple systems and are processed parallelly. For a small data object, for a very small data object, splitting, storing, again retrieving is a time-taking process, right? So for that you can just go with this databases itself, right? So here we are meant for batch processing. One thing is batch processing. Okay, so millions and trillions of records processing, right, by dividing and partitioning into multiple parts, storing across multiple systems and processing it. So it doesn't, once again, online processing means client server architecture, client giving the request, server giving the response, right, for this. But if you want to perform this kind of processing also possible, I'm not saying directly not possible, indirect. So if you want integration with NoSQL databases, either Spark integration or Hadoop integration with NoSQL databases, where this Spark can perform batch processing and this NoSQL can perform online processing. Both combinedly can perform both batch and online processing. See, one thing, in real time we will see a lot of integrations, right? Yes. So here Spark. So if you want the online processing, NoSQL databases are available. Cassandra, MongoDB, HBase, right? So this can perform batch processing. Batch processing means where user non-interactive applications, where huge NoSQL databases means you can perform only on a single record updation. Here you can update only single record, but for massive updations, you go for Spark or Hive, massive updations, lakhs of records updating. NoSQL is for online processing. Combinedly, both can perform batch and online processing. And if you want live streaming data also, if you want to work with live streaming or capturing live streaming data and processing it, right? So Spark can process. So you need to integrate with Kafka. Kafka is for live streaming and even for live streaming and messaging also. Okay, so these things, if you want to be used for different, right, batch and online processing, and for streaming processing, for streaming also, right? Yes. And Spark real-time processing, we say. Spark is real-time processing. We can perform real-time processing. See, for example, today some 1,000 transactions happened. At the end of the day, you have detected some 20 fraud transactions happened. 20 fraud transactions happened, right? But what is that? Immediately whenever fraud happened, what do you mean by real-time processing? Means immediately whenever fraud happens, then saying that the fraud has happened, right? So not after 1,000 transactions happen at the end of the day saying that some, but real-time processing means then and they're saying that a fraud has happened. So today fraud happened, after 2 days detecting that fraud has happened. That is not, but real-time Spark can go for real-time processing. Means, see, for example, if you take Spark and this live streaming. So if I talk about live streaming data, I was saying like yesterday, I was saying like Spark used to, even for Netflix is using Spark today. Events are generating. Live streaming means events are keeps on generating means at the same rate of speed, the data need to be processed at the same rate of speed. The data need to be processed. Means we need to have a very high speed processing technology like Spark, right? For that. So at the rate of speed of the events generation should match the rate of the processing it. So Spark can do it. At one side events generating, at the other side Spark will be processing the events at a high speed. So yes, Ramu ji, and how to work with this, see what is the data bricks and how to work on it, right? Everything I'll be discussing as part of this. Not only that, different environments I'll be discussing like data bricks and how to work with Anaconda distributions like Jupyter, even on IDs like PyCharm and IDs like even IntelliJ also I'll be showing you, right? And also like in the cluster level on VM, how to do that, everything, multiple ways I'll show you, right? Even on Google Colab also how you can work, right? Yes. Okay.
Hello. Yeah, actually, yesterday I did not attend the class. I'm not sure whether you covered this point in the yesterday session. This is the question I have is, so what is the prerequisite? Do I need to have the understanding of the Spark system and how it will work to attend this session? Just I want to know the prerequisite of this one to attend this.
Everything Spark execution model, everything I'll be discussing in brief. Not required. Spark execution model in brief I'll be discussing. Spark features, computation, persistence, fault tolerance, lazy evolutions, in-memory computations, how processing happening, and where are the different persistence levels, fault tolerance.
Spark ecosystem, all about Spark ecosystem.
Yeah, Spark ecosystems. Everything we'll be discussing as part of. No need, right? Yes.
So what is the duration of this session? I mean, this.
So it's a weekend batch. It goes for 10 weekends.
So per weekend, how many hours?
So 1 second. So every week it goes for 4:30 to 6:30 or 7 it goes. 4:30 to every day. It means every Saturday and Sunday. 2.5 hours on Saturday and Sunday. It means 4 to 5 hours per week you'll be getting. So it goes for nearly, if you go for 10 weeks, 45 to 50 hours we'll be spending on this, right? So I'll just once again I'll show you what I'm going to cover as part of this, right?
Yeah, that would be very good. Thank you.
Okay, and one thing, just observe how the Spark, just I'll give you overview as of now to just understand how the Spark data objects, we call it as RTD. Spark data objects. if you are loading any file, if you load the file path you provide file path some f1.txt file. So from that, using Spark context, if we load that file path, then RTD getting created. RTD has got, think that you got some lakhs of records. From RTD1, if you perform any transformations from R1, R2 getting created. From R1, R2 getting created. How R2 getting created? R1 has got 10 lakh records. If you filter, you got some 6 lakh records. 6 lakh records means R1 has got 10 lakh, R2 has got 6 lakh. Okay. From R1, R2 getting generated. From R2 again, for example, all the employee names, 6 lakh employee names, starting with lowercase. I want to just transform all the employee names to uppercase. Map operation, map functionality. Again, you get R3. In R3, you see all the employee names in uppercase. Otherwise, some IP address I'm generating from the whatever the location. From their locations, I want to know their IP addresses. Or from the IP addresses, I want their city names to be generated. Or from R3, R4 gets generated. Some transformation, grouping operation or sorting operations. Means here, okay, R4 to R5. Observe carefully. This entire flow we call it as a data flow. Data flow, right? Data of 10 lakh records, 6 lakh. Again, here I want only particular Hyderabad city records only I want. Again, filtering happened, only 3 lakh records you got. Means data flow, right? So this data flow executes only if you perform some kind of action. Action means you got some, for example, R5 dot collect or dot action. Later I discuss what are that. Whenever you perform this action, right, then only from the root to this, first R1 gets loaded into the RAM. First R1 gets loaded into the RAM. R1 divided into multiple partitions and gets loaded into the RAM and processed. Next, once the processing finished, once that execution is finished, right? So the result R2. Now when R2 is ready, see one thing, the RTD size is very large. Think it is some 10 TB or some 5 TB, or at least you say 2 TB it is. To accommodate 2 TB, how much RAM capacity? 2 TB RAM need to be maintained. 2 TB RAM need to be maintained because all the data to be stored within the RAM level, right? But 1 RTD 2 TB means 5 RTDs. How much TB required? 1 RTD 2 TB means 5 RTDs. Data 10 TB, right? To provide 10 TB RAM means it is a huge task, right? So here RTD is resilient distributed data set, RDD, means all these RTDs at a time they won't be loaded into RAM. If at a time they are loaded into RAM, they cannot be accommodated into RAM. They cannot be accommodated into RAM, right? You cannot provide that much of space, right, to accommodate all this RTD. When R2 from R1, R2 got created, R2 got computed, R2 computation finished, then R1 will be removed from the RAM. Observe here, R1 gets removed, R1 and its partition gets removed. Now what is present within the RAM? R2 is present within the RAM and R2 partitions are present within the RAM, right? Yes. Okay.
Sir, how it will remove R1 automatically, or like we will need to?
No, automatically. So
Automatic.
that is the feature, right? So when R2 is ready and computed, all the R1 partition gets removed.
So
Now
it's removed from the memory or HDFS, like hard disk?
from the memory,
Okay, backup will
So,
be available in the hard disk.
so whatever we are talking is in-memory computation, memory level, right? So once from R2 to R2 partitions load across the RAMs of multiple systems. Now R3, the result whatever we get R3. Now when R3 is computed and processed, when R3 is ready, R2 gets removed from the RAM. Only the current RTD will be present within the RAM. When now R3 output is there within the RAM, R3 output is taken as input by, see here, once R1 output is taken as input by R2, R2 output is taken as input by R3, R3 output is taken as input by R4, right? Once R3 is ready, R2 got removed. Now R4 computation finished, loaded and computed into the RAM. Processing finished. Now R3 gets removed. Now R4 loaded, computed. Now when R5 is ready and R4 gets removed. Once the total execution finished, once the R5 output is collected, final output is collected, R5 also gets removed from the RAM. Now what is present within the RAM? Now what is present within the RAM? Which RTD present in the RAM?
Right.
R5 also removed from the RAM when output is closed.
Output, R5 output.
Now what is present within the RAM means nothing. No RTD present within the RAM. All got removed. One by one RTD gets loaded, they gets removed. And finally, if you come to that, right, all the once the output is corrected, that R5 also removed. Now no RTD in the RAM. Now next you can trigger the next flow. If you trigger the next flow, once next data flow, again the next data flow also one by one RTD. Triggering means once you perform the action only the data flow gets executed, right? Next flow also one by one RTD they get loaded and they will be processed.
Sir, then where the output will be stored, the final output?
Final output will be stored at the client side. The system from where you are triggering, right? From where you are performing that, from where you are submitting the job. Okay. So the final output will be collected by the client from where you are submitting the job, right?
So it could be like from the client database or the data lake somewhere, or it could be from the HDFS also, right?
So if you got a group of cluster, right?
Yeah.
A number of systems, it can be one of it also.
I mean, within the worker nodes, within the
worker nodes also.
Okay. So then, actually, we may not have sufficient memory,
so,
right?
See, what do you mean by the client means?
Client mean the end data from the end database or the source database.
The machine from where you are submitting it.
Right.
That output for that machine is going to collect the output.
Okay.
That is going to collect the output, right? And in the RAMs, what is present means nothing is present. Now the RAMs are free. Now the RAM is free. Now you can trigger the next flow also. But in this case, now I'll just say one more example. R1, R2, R3 means I want to perform. See, aggregations, right? Sum aggregation, average aggregation, max aggregation, min aggregation. All this you are applying on salary, right? For example, sum of salary, total salary, what is average salary, max salary, min salary. Means my R3 transformation is extraction of salary. From there onwards, R4 means sum I want to calculate. From there you want to perform something, R5. From R3 again, R6, R7. From there, R8, R9 means this R3 output used by this flow. This is the first flow. This is the second flow. This is the third flow.
Right. Here data is persisted at R3.
3 flows are there. But 3 flows, first flow, if you want to execute this first flow 1, you will trigger R5 dot action. R5 dot action means first R1 loads, R2 loads, R3 loads, R4 and R5. When R2 ready, R1 removes. When R3 ready, R2 removes. When R4, R3 gets removed. When R5, R4 gets removed. Finally, this R5 also removed. The output collected from that flow 1. If you trigger this flow 1, Flow 2, if you want to execute flow 2, see R1, R2, R3, R6, R7 dot action, you will say. So from R1, R2, R3, R6, R7. So once they get loaded, the previous one gets removed. Finally, the output is collected. Now what is present? Nothing. Similarly, flow 3 also. But what is your observation here also? R1, R2, R3, R8, R9. So here also everyone, they get loaded and removed, loaded and removed, loaded and removed, output collected. And in all the flows, first 3 steps are common, right? In all these flows, first 3 steps are common or not?
Yes.
Yes, sir.
When you are executing the first flow, okay, why are you re-executing again this first 3 steps again? Already you have executed here, right? Means here you are unable to use this R3 output, and for R6 directly can use R3 output, right?
Right.
Already R1, R2, R3 is there. R3 you computed previously in flow 1. Directly I can use R3 output and compute R6, right? Why again you are computing R1, R2, R3? Already in flow 1, R1, R2, R3 computed. The R3 result directly can use by R6, right? But
Because it is removed from memory.
Yeah, it is removed from the memory. It's not available in the memory to get the output of R3 by R6 or R8. If I persist it means, persisting means even though the next RTD processed, it will be still available in the, it won't be removed from the RAM. For example, now you persist, now you see the first flow, R1, R2, R3, R4, R5. When R1, R2 ready, R1 removed. When R3 ready, R2 removed. When R4 ready and processed, R3 will it be removed?
No.
R3 won't be removed, right?
Yes.
When R5 is processed and ready and R4 gets removed, final output collected R5. Now what is available in the RAM? R3 available in the RAM, right? When R3 available in the RAM, flow 2 what it can do? Directly your execution flow will start from R3 is ready to give the output, and R6 takes this output of this and as input and computes R3, R6, R7. That's it, right? Only a small flow. We are no need to execute from the starting, right? R3 is available within the RAM to give its output to the next flow. Similarly, in flow 3 also, no need to execute. R3 is available. See, R6 is ready, R3 won't remove. R7 ready, R6 removed. When total output collected, R7 also removed. Now what is present? R3 present. Now when R3 is present, directly I can say R3, directly R3 output we can take, and R8 will be computed. R8 and R9. Now once the execution finished, all this will be removed, only R3 will be available. Means here you may ask what advantage you are getting. Here it is a small flow, but if it is a bigger data flow, right? Yes.
So, sir, someone has to design this workflow, right?
R1, R2, yes, I'm coming to that. R50 is there. R50 is output used by R60, R70, R80. First, this flow executed. Your persist. Now I'm talking about persist feature and transformation, reusing, and what is lazy evolutions. These 3 to make you understand, right? Later I'll be discussing all this with multiple examples. So here, first flow executed. Second flow, R50 available in the RAM or not? Yes, try to respond. I want the sessions to be interactive, right? So that your answers are correct or wrong, you can keep responding. You can unmute yourself, give your responses through voice or through chat panel. So R50 available, right? R50 available means flow to directly node to need to execute the first 50 steps directly 50 to R70 2 steps enough. Because R50
So
is
someone has to make R50 as
persist. Yes,
persist,
means
right? Then only it will be
so
it will not be removed, no?
So we will be writing, we will be designing those things. Which output is used by multiple flows, you will come to know, right? In all the 3 flows, which output is used by different flows, that you will be persist. So here 50 steps decreased, no need to re-execute again and again. So we are just persisting it, it can be reused. Means here the advantage is reusing feature and persistence feature. Okay, fine. Okay, so this is just overview of this RTDS and computations. Next session I'll be discussing in brief, right, with clear notes, with multiple examples how this computation happens, the other things, right? Just it looks very simple and easy. So even I said why we are using this, someone was asking, right, why Python is preferred, means Python itself very less coding, simple syntaxes, looks like normal English statements. It has got wide varieties of many built-in libraries or modules, I can say. Using, we don't need to write huge codings. By using them directly, we can perform the operations, right? So Python, very less coding. It's not very complex. They're like Java. We are not writing huge codings here. So anybody can update with this PySpark. The only thing is you need to just do the.
Not able to see your screen.
Everyone not able to see my screen?
I'm able to see only paint screen.
Paint, yes, that is the only thing that's talking, right? Fine. Okay. Now this is what the course content I'm going to discuss as part of.
One question. Do we need HDFS, Hadoop, or high knowledge for these sessions?
So one thing, HDFS, before I go with the practical part, right, just I'll be providing. So if people who doesn't have the knowledge of those prerequisites, right, I'll be forwarding the videos of those, right? HDFS, like 1-2 videos of it, right? It's simple commands, simple one-line commands, right? So those commands, either if I discuss any Hadoop session, right, I'll ask you to join that. Otherwise, I'll forward the video if it doesn't have knowledge on HDFS. You need to know about HDFS commands, right? Just 1 or 2 videos is you need to just to go through to understand it, what it is. Later, if you got any queries on that also, you can ask me during the at the end of the session.
Okay. And when we are pursuing some kind of job in the market, just with PySpark, were we able to pursue some positions?
You're talking,
and
when you are submitting Spark job, you're talking.
Not the Spark jobs. I'm talking about jobs in general.
Okay. So when you are going for for interviews, right? So the things, what are the roles, responsibilities, the resumes, everything I'll be guiding you at the end of the course end, right? Yes. Okay. The roles, responsibilities, and the flow, everything I'll be discussing, right? So this is what the course content I'm going to discuss in brief, in depth, right? With multiple examples, PySpark RTD computations, RTD, just I was talking about RTD, right? What is an RTD? RTD actions, transformations, RTD persistence features, in memory only, memory underscore serialized, disk only, disk underscore SCR, memory and disk only, right? And PySpark core computing, fault tolerance, different ways of creating, increasing the partitions, aggregations, groupings, single grouping, multi-grouping, multiple aggregations, group by key, reduce by key, various transformations, various inbuilt transformations, count by key, count by value, union, distinct, joins, PySpark SQL. PySpark SQL means data frame, making data structured, creating data frames from data frame to pandas, struct type, row class, with column renamed, where, filter, drop, order by, join, group. So all these are inbuilt